Okay, so thank you very much. Thank you, Lorena. Well, as most of you know, we're also another of the pilot sites of the Rotate project, and now we're gonna tell you a bit about us and about the project. First of all, we operate in Soria, which is a small region in the northeast of Spain, where we operate two quarries, and we also have ready-mix concrete plants, and with also other civil construction and everything. And the main site where we're focusing today, it's our El Tomillar sand and gravel quarry in Soria, which is where the Rotate project takes place as per our site. First, I want to introduce a bit, because this is a sand and gravel quarry based on alluvial deposits, which is interesting, and I will explain it further later. Because one of the things we changed here from the beginning is that at the very beginning we were just extracting the first, let's say, the shore of the terrain. But after in 2004, 2007, we achieved a live project, a live eco mining project. We discovered that with we could mine the quarry in a different way. Going up to 35 meters below floor. And this has really a big impact on, as we will see later on, the concentration of raw materials, critical raw materials that we are able to extract. Well, as you see, it's also very compromised within the environment. We have CO2 capture projects. We take really serious all the environment stuff, and we really think it's the way. So our role in the project, it all began, I think it was in 2017, something like that, where we initially tested a really initial prototype, quite small, and it's where we acknowledged that within our sand, in the finest particles, below 0.5 millimeters, it's where we could find critical raw materials and rare earth elements, along with other valuable, let's say, elements. And so after we started in the Rotate project, it's where we, inside our whole cycle, implemented an all-in-line pilot plant, semi-industrial scale, but not lab concept, as was the first initial pilot, but a real operation plant. Basically, what we do is from our cyclone, we separate at 25% of our fine fraction. We drive it into the pilot site, where we, after this primer screening, we do a gravimetry, hydraulic classification with another cyclone, which allows us to take the, as I said, the smaller than 0.5 millimeter particles. We put them into the spirals. It's similar somehow to what Noemi just explained. And after that, we obtain a pre-concentrate that afterwards we characterize. I will explain a bit more about the process later, but why we think it's, or why is it important, or we think, why we know it's important. First of all, it's because with this project, what we are proving is that it's a fact that conventional aggregate quarries can become a secondary source of critical raw materials and rare earth elements for the European Union, without disrupting the existing production, as all the plant it's added to the already existing plant. It also proves that you can move from a lab concept to a really functioning semi-industrial pilot plant, integrating not only advanced separation techniques, but also the real-world techniques that most of the quarries use nowadays, also in their production processes, can be used to generate this semi-concentrated of materials. The initial results show that there is a full potential for these plants to perform. There's some fine-tuning needed. We have seen that the concentrates we're obtaining are a bit less concentrated than we thought in the initial stages, and what we worked in 2017 might be probably because of the flow effect. Now the flow has been increased. We are producing between 13 and 18 tons of dry concentrate per day, which means that we are passing through the pilot side 25 tons per hour in a 2-shift day, which is 16 hours of work. So the time that the material stays on the plant, it's lower, because we are not achieving yet to reduce the power of the pumps, so without disrupting the production, and it's making us that perhaps the initial concentrates we're obtaining are, as I said, a bit less concentrated than what we expected, but still we think it's been a success of a project. How this really works, as I already said, we struck the raw material from the land. We transport it to our plant, to initial plant. When we are starting to clean it, the slurry it's pumped into the system. It's really controlled the flow and the pressure. As I said, disruptions on the pressure affect a lot in the production of the main plant. Then we continue with the hydraulic classification with an additional hydrocyclone we placed there with AMP, which has designed all the plant, and separates particles by size and density, concentrating the fine fraction where all these valuable minerals are present. Then through the spirals in the gravimetric concentration, through the density, we separate the heavy mineral fractions from lighter silicate materials. Afterwards, with barytic skins, we do a dewatering process, and we finally recover, let's say, what we call these concentrates. What have we find out? It's that we need to do a further grade enhancement of the concentrates, which nowadays is out of the scope. But it might be necessary if we want the real economic viability of a future industrial scale plant, because nowadays there's a lot of gangue in the concentrates, which we have to somehow reduce. We have to increase the grade of and the purity of the target minerals within the samples, within the projects. What have we found within our quarry, and what have we found in these concentrates? Mainly monazite, xenotite, zircon, ilmenite, and rutile. A lot of critical raw materials contained inside, used for advanced electronics, EVs, wind energy. There's as I explained in the beginning, we're exploiting up to 35 meters. So as you could imagine, we are now facing some challenges, because if we don't mark really well the initial samples that we're later on analyzing with CTM on lab, we are a bit lost, because there's a huge dispersion, there's a huge heterogeneity between the different, let's say, bulk of concentrates that we are obtaining. We're on the shore of Alberto River in Spain. There's a huge concentration of these materials, but depending on the level on which you are and the distance to the river, and also the let's say the proportion of sand and gravel of the part that you're using on the plant, feeding the plant with, there's a huge dispersion. And now this is one of the main challenges. We have to organize these per-concentrates in different lots, that when we test them through the CPI and ICP and SEM analysis, we can really take some clues and understand where are the main places where we can obtain the different minerals we have within the quarry. As I said, we have already proven the viability, despite this fine-tuning that we have to do, which mainly consists on introducing later some vibrating tables, probably another cyclone. We have to fine-tune the power of the plant and the speed at which we can work with the plant. But with this future grade enhancement, we are sure that this will become more than viable, not only on the economic standpoint, which of course it's the driver in the case of if we want to translate this into a full industrial scale where we process the 100% of our production, but also on an environmental and operational standpoints. When I will speak about the environmental, I also link it to the circularity of this project, which is quite important for everybody and especially for us, because this reduces a lot the water consumption as we recirculate all the water consumption from this plant and the other ones, and they are always going back to the initial hydrocyclones in order to take the advantage of reusing all the parts we can from them. And we have already tested with CTM again the residual sludge we produce, which is one of the key points. And in the live project, I told you it was the main point, was what to do with that sludge and how to treat it. And now still we are generating a lot of byproduct that we think we can reutilize. The other day we were speaking with Antonio from CTM, and what we learned it's we might be losing some of these critical raw materials in the sludge, as the finest particles of dust are driven through the water with this sludge. And also it's we have to work, and it's already shown that there's not a huge energy consumption by introducing this new plant, as it's all in line with the initial plant. For us, the most important part from this, let's say not as a local point of view, but as the project wants to show at a European, let's say, standpoint, it's that we're somehow showing that you don't need specific quarries to obtain these materials, but that existing quarries in Europe in general and alliances through small and medium-sized pods, as can be CTM, AMP, Hormisoria, ANEFA, are the future to create a real alternative for the European viability of the production and alternative to this CRM production, which nowadays it's, as we all know, outside of Europe. So what we say, it's the quarry of the future that's not just extract aggregates, but also recovers strategic resources and puts into value all the natural resources we have within quarries. So just to finish, let's say that the project, it's been a success. It's a complete success. There's still a lot of work to do. The future will require, of course, new stages, but we think that an ideal future in which small quarries can feed Europe with these materials is possible, and this is the proof that it is. So thank you very much.